Here we go again. Section 12.2 is on evaluating limits algebraically. In section 12.1, we were estimating limits using a table. The tables can be long and tedious, and they really aren't that great because not only are they long and tedious, but they only give us an estimate of what the answer should be. It doesn't even calculate an exact value for us. So what section 12.2 starts with is some properties of limits, and we can use those properties so that we do not need to make a table anymore, and instead of coming up with just an estimate, we actually come up with the exact answer. The material for 12.2, day number 1, is not extremely difficult, but it is a bit tedious, and the way the book writes it up can be kind of confusing. So for this first video in section 12.2, I'm just going to reference the properties that are in the book and show you what it looks like when they write out the properties in the book, and then give you an example of each one. You do not need to take any notes off of these properties if you don't want to. When I do the second video for 12.2 day 1 and start going through example 1, then you'll want to copy those down, and that'll help you out with your homework. You certainly can take notes on this if you'd like, but I'll be doing a lot of referencing, and take notes as you see fit. On page 746 in our book, there are all of these different properties. In the top half of the page, there is a couple of properties of limits. One is a limit of a constant function. One of them is a limit of an identity function. And then further down on the page, we have in a box the rest of the properties. There are 7 more properties down there. So there are 9 properties total. These 7 properties that are down at the bottom, those are properties that we're going to use to take something complicated and break them down into smaller pieces. These 2 that we have up at the top, those are ones that we are going to use in order to actually do some evaluating. So these we're going to use to break up into pieces, something that's complicated, and then when we're actually calculating the answer, we're going to just be using these 2 at the top. This sheet right here I am going to upload onto Google Classroom, and it will be accessible along with the exercises when you take a look at that area right below where the videos are posted. Okay, so to start with, let me talk about these top 2. The first one that I want to talk about is actually the second one that was listed, and here's what that one looks like. This is the limit of the identity function, and this is what it looks like in the book. It's the limit LIM as x approaches c of x, and that's going to be equal to something. Let me show you an example of what this is. The c that they are talking about here is going to be some constant. That's what the c stands for. So an example of how we could go through and use this property would be if we had a problem that looked like this. If we had the limit as x approaches some constant, I'm going to pick 5 for this. The limit as x approaches 5 of x. I want to see what that is equal to. What the property does, what the property tells us we need to do, and what we'll be doing in all of the problems, is we're going to be taking, when we have the limit as x approaches a constant of x, we're going to take this constant and we're going to plug it in here for the x. Basically, we're just substituting in this constant into the x, so that is equal to 5. So the property, if you were to take a look at the book, says the limit as x approaches c of x. That's always going to be equal to whatever this constant term is, because we just substituted in there to get the answer. So in the book, they would say the limit as x approaches c of x is equal to c when they list out that property generically. When we do it, it's going to look something like this. And if I change this number here, all it does is change the number out here on the outside. So if we were to go through and do another problem, and instead of having a constant, where the limit was approaching 5. Let's say we have the limit as x approaches -3 of x. Well, when you just have an x here, you just take this number, you plug it in, and that just gives you that value. So that is the limit of the identity function. That is the second one that is listed on page 746, and the second one that was on my list earlier. The one right below that, or right above that actually on the list, is called the limit of constant functions. And in the textbook, it looks like this. On the left side of the equal sign, we have the limit as x approaches c of some constant. C is a constant, and the constant here in this part of the problem might be different, so they're going to choose a different variable. It's not really a variable, actually. It's a constant, but they're going to use a different letter, and they're going to use k. So they use c for this constant, and then they're using k for the other constant. These two numbers sometimes are the same. Most of the time they're different. And that is going to be equal to something. To show you an example, just to kind of show you what that looks like, if we did the limit as x approaches 7 of 10, well, if we think of it how we did that last example, that for the limit of the identity function, what we did here is we took this number, this constant, plugged it in for the x. That gave us our answer. In this problem, if you take 7 and you plug it in for the variables, well, there aren't any. There's not a variable there. So when you plug 7 in, it doesn't change this at all. It still just stays the same. So if you have a constant here, you don't end up plugging this number in anywhere, and the answer just ends up being the constant. So in the book, when they do it generically, they're going to say the limit as x approaches some constant of another constant is just equal to whatever this second constant is. It's just equal to k. So those are the first two that are on my list. I'm going to go through and talk about the next 7. So in the box that I showed you at the beginning of the video, there are 7 properties. The first one looked like this. It is the sum property. And what that says is if you have a limit of 2 things being added together, you can break that apart into 2 pieces with 2 limits. So an example of what that might look like is this. We might have the limit as x approaches 3 of 2 things being added together. Let's say x squared plus 2x. Okay? So that's like f of x and g of x. What that's going to be equal to is this. This limit will go in front of each one of these, and we can break it into 2 separate limits. So it's going to be the limit as x approaches 3 of this first part, plus, and then another limit, the limit as x approaches 3 of the second part, which is the 2x. So we had a limit of 2 things being added together. Now we have a limit plus another limit. We've separated that. We've divided that up into 2 parts. The difference property is very, very similar. The only thing that is different with it is that there is a subtraction that is in between. So instead of f of x plus g of x, it's f of x minus g of x. Without doing a complete brand new example, let me just change this one. If this original problem, instead of addition in between here, had subtraction, all that would do is change the sign in between the 2 separate limits into a subtraction. So the sum and difference property allow you to take 2 different terms that are being added or subtracted and write them as 2 separate limits instead of 1. We're taking something that's more complicated, a 2-term polynomial, and we're breaking it up into 2 smaller parts. Again, that's the whole point of these properties, is to be able to go through and take things and break them up into smaller pieces. There are 2 multiplication properties. There is something called a scalar multiple. A scalar multiple just means a number multiplied by a variable or times a term. So for this one, an example we could use would be the limit as x approaches 10 of 8x. So that is like the left side here in the formula. K is a constant, that's like the 8, and then f of x, that could be an x or an x squared, it could be all sorts of different things, but it's going to be a constant times something with a variable. And if you look at what happens on the right side of the equal sign, the constant just comes in front of the limit instead. So the k gets pulled to the front. In this case, we're looking at an 8 as our constant. So it's going to be 8 times the limit as x approaches 10 of x. So that's the scalar multiplication property. There is also a product property. That's where you have two things with variables being multiplied together. And this is very similar to the addition and subtraction one that I had earlier. So an example of this one would be the limit as x approaches -2 of x plus 3 times x minus 1. Let me line that up a little bit better. So here is our limit with our two things being multiplied together. So that's our limit, and f of x is like the x plus 3, g of x is like the x minus 1, and then that's going to be equal to, and if you look at what happens on the right side, you can break this up into two separate limits with multiplication in between, instead of one limit with two things being multiplied together. So it's going to be the limit as x approaches c, which is our -2 there. So the limit as x approaches -2 of the first value, which is an x plus 3. And then that's going to be times a second limit, the limit as x approaches -2 again, of our second set of parentheses there. So one limit with two things being multiplied together, you can break that up into two separate limits. So that is a scalar and a product property. There is a quotient property, and that is handled much how you would think it would be handled. I guess there are 8 properties in that bottom box. I think I said 7 earlier. So if you had the limit as x approaches a constant, like x minus 7 over x squared, and this has to approach some value, some number. So let me again pick just kind of a random constant there. So the limit as x approaches 3 of x minus 7 over x squared, so that's a fraction. What this property allows you to do is to split that up into a fraction with a limit on the top and a limit on the bottom. So we'll copy this limit down twice. We'll do the limit as x approaches 3 on both the top and the bottom of this x minus 7, and then the x squared would go down on the bottom. So x minus 7 up here on the top, and then the x squared down on the bottom. So the quotient property allows you to take, again, a limit with a fraction and write it with the limit on the top and on the bottom. That's our quotient property. There is a power property. For the power property, that's when you have something raised to a power. So for instance, if we have the limit as x approaches a constant again, like 4, of something raised to a power, let's say x squared. What that allows you to do is to put the limit and the base of the exponent on the inside of these brackets, and then on the outside would be your exponent. So this would be equal to the limit as x approaches 4 of x, and then we have the squared on the outside. The nth root property is similar. We're just dealing with roots instead. So if we did the limit as x approaches 7 of the square root of x, we can put the square root over the entire limit, like that. And that is how you use the nth root property.